As a participant in the OGC Open Routing API pilot, Ecere provided components based on its GNOSIS geospatial software technology for the project. Those components included a routing engine, as well as a desktop 3D map client application. We also produced geopackages of the roads network sourced from OpenStreetMap, intended for use by routing engines. Both the engine and the client were used in numerous combinations of technology interoperability experiments with components from other participants, including both online and offline scenarios. In the simplest setup, our client embeds the routing engine and makes use of it directly for calculating routes offline. As a GNOSIS client can also visualize compact, optimized maps offline, this is ideal for mobile or limited connectivity scenarios. The client can also connect to online Open Routing API endpoints, which will perform the route calculation. We provided the bare-bones implementation of such an API, which processes routing requests using our own engine. Other participants also deployed Open Routing API's implementations, which made use of our routing engine through this endpoint and could also connect to other routing engines. The communication mechanism between the routing client and the routing endpoint is defined by the Open Routing API specifications designed during the pilot. Our client sends out an HTTP POST request, embedding a JSON object with the parameters of the route calculation to perform. The routing endpoint then returns a GeoJSON object according to the route exchange model, including an overview of the whole route and a description of the road segments, with properties indicating, for example, the name of the road, the distance, the duration, the speed limit. The routing endpoints may support additional parameters, such as specifying which routing engine, which dataset, or which algorithm to use, a preference for fastest or shortest route, additional waypoints, weight or height restrictions, or regions to avoid. The routing engine we developed during this pilot implements the A* algorithm. It is written using the Ecere programming language and is compiled natively to achieve optimal performance. Its design included scalability considerations, such as the ability to distribute the computation of roads to parallel threads running on different CPU cores. The roads network is assembled from original OpenStreetMap data sourced from the OSM PBF format. The same source vector data is also used in our client for visualizing the OpenStreetMap overlays. Our routing engine was also made available to other participants as a command line interface executable. This enables its use in offline scenarios by other client applications, as well as avoiding an extra server round trip for integration in other routing endpoints. In the pilot, most routing experiments were performed with a small subset of the OpenStreetMap data for the Washington, D.C. area. However, we also experimented with larger amounts of data, such as the entire state of North Carolina, as well as large regions in Japan. These larger data sets allowed to put our routing engine's performance to a more stringent test and really showcase its potential. Despite the early stage of development, the performance so far has proved to be quite satisfactory. The future optimized version of our routing engine should be able to achieve even better performance and leverage multiple CPU cores, with an end goal of calculating continent-wide routes from a worldwide OpenStreetMap dataset in just a few milliseconds. Another improvement we hope to achieve in the future is taking elevation into account for calculating energy-efficient routes.